So, given the answers, 36 for example, find all the questions, the factor pairs. You'll see a sheet that's in your divisibility rules in your handout. Divisibility rules, right. So with the tiles, they can identify the divisors or the factor pairs by looking at numbers that divide evenly into numbers, right? For example, if 20 has a factor pair of 2 times 10, it's divisible by 2, it's divisible by 10. Correct? Meaning it divides without a remainder. So a number is divisible by another number if when you divide it, there's no remainder. Okay? So this is actually used to be high school language, which has now moved into the intermediate grades and should be started in grade 4, I think, grade 3, whatever. So use the divisibility rules to find factors of numbers, to find factor pairs. Does that make sense to you? Okay, great. 2, a number is divisible by 2 if it ends in a 0, 2, 4, 6, or 8. Have you heard of digital sum before? It's really cool. A number is divisible by 3 if when you add the digits together it is a 3, 6, or a 9. It's like a huge trick. The kids they just embrace it. What? I can tell if 3 goes into a number by just adding the digits? Try it. How about 45? Is it divisible by 3? And you're all thinking, yeah, I know, 3 times 15 is 45. But kids don't know that, right? Is 45 divisible by 3? Add 4 plus 5, you get 9. Yes, it is. Is 624 divisible by 3? Add the digits. 6 and 2 is 8, plus 4 is 12. Now keep adding. 1 and 2, you get 3. Yes, it is divisible by 3. How could you use this in real life? This is what I always say. Well, if you had 612 people and you want to know if they were all going to fit in tables of 3. Yeah, right. Okay. Like every week we do that, right? But it has an application, and it's mostly applicable. And yes? Exactly. There you go. Perfect. And the kids will come up with great examples. Really, what is the best part of it, though, is that you get to know numbers. And they're not scary anymore. So you'll notice that the fantastic factor sheets go up to 100. It's really helpful to know the factors of numbers up to 100. So helpful in so many areas. Can I go on from here now? Number is evenly divisible by 5 if the last digit of the number is a 5 or a 0. By 4 if, when you divide it by 2, you end up with an even number, because you could then divide that by 2 again. And then by 10 if the number ends in 0. So I love rainbows, and I love how kids love them. You see these rainbows here that show all the factor pairs of a number in a row, starting with the lowest and going to the highest. They love using crayons. They love how they look. 97? All right, here we go. 90, okay, 97. All right, we'll check and see. Is it divisible by 2? No, because it's not even. Is it divisible by 3? Add 9 plus 7 and we get 16. Add 1 plus 6 and we get 7. No, not divisible by 3. Is it divisible by 4? No, because it wasn't divisible by 2. How about 5? No, doesn't end in 5 or 0. How about 10? That's the other one we know how to check, right? How about 10? Nope, doesn't end in a 0. So we might try a few other numbers, but really we're getting to the spot where we think it's not divisible by anything except 1 and itself. And what does it become? Prime. If you look at 97 on your sheet, how many lines are beside 97? 1 line. Gives it away. And there's another visual representation of all the prime numbers between 1 and 100. Every one of those that has only 1 line beside it is prime. So I have students go through and would you please write down where there's only 1 line, would you write 1 times that number? And then would you circle it in a color that you want to associate with prime numbers? And then look at how many there are. And then talk about what's a prime number between this number and this number. And everybody looks, oh, wow, 37 is or whatever, you know? Okay? You make it part of their talk. They can see it. They recognize its order in the numbers between 1 and 100. And they have a reason for proving that there isn't anything else that divides evenly into 97. They can pull out their calculators and to try and divide it by 17 or something, some other prime number, right? Just to prove it. Work in a group. Can you prove that 97 is a prime number? I only gave you one line, but maybe I made a mistake, you know? That kind of thing. Okay. So rainbows. And we have rainbows all over the classroom. Kids take numbers and they say, oh, I'm going to make a rainbow of this and put them up everywhere on the bulletin board outside the classroom.